imagine holding a piece of the night sky in your hand. Not a metaphor, not a dark fabric, but a literal void. You hold it up to the light, but the light doesn't bounce back. It disappears. You look at it, but your eyes cannot focus on its surface because there is no surface to see. It looks like a hole cut out of reality itself, a flat, two-dimensional tear in the fabric of the universe. If you look closely enough, you might feel a sudden, creeping sense of vertigo, as if you are staring directly into the abyss, and the abyss is staring right back into you. For thousands of years, humans believed that black was simply the absence of light. We thought we understood it. We saw it in charcoal, in obsidian, in the deepest caves, and in the velvet expanse of a moonless night. But we were wrong. What we called black was merely a shadow, a faint imitation of a terrifying truth. In the hidden corners of nature, and inside the most advanced laboratories on the planet, a secret race has been unfolding. A race to find, and to create, the blackest thing on Earth. This is not a story about color. It is a story about a substance so dark that it eats light alive, a material so absolute that it defies physics, and a journey into a darkness so profound that it changes how we see reality itself. To understand the search for the absolute dark, we must first understand the lie our eyes tell us every single day. Look around you. The world is a canvas of colors, reflections, and textures. You see a red apple because the apple absorbs every wavelength of light except red, which bounces off the skin and strikes your retina. You see a white sheet of paper because it reflects almost all the light that hits it. And you see a black leather jacket because it absorbs most of the light, reflecting only a tiny fraction back to your eyes. Keyword, most. The blackest paint you can buy at a hardware store still reflects about 5 to 10% of the light that hits it. Even the darkest charcoal reflects enough light for your eyes to discern its texture, its curves, and its three-dimensional shape. This is why you can see the folds in a black shirt or the wrinkles on a black piece of paper. Your brain uses those tiny reflections, those microscopic glints of light, to map the world. But what happens when you remove the reflection entirely? What happens when light goes into an object and never comes out? For a long time, scientists believed nature held the crown for absolute darkness. And for good reason. Deep within the dense rainforests of Papua New Guinea lives the bird of paradise. To the untrained eye, the male bird is a stunning spectacle of vibrant blues and greens. But surrounding those bright colors is a patch of feathers so intensely black that it looks like an optical illusion. For decades, biologists were baffled by these feathers. When they placed them under high-powered microscopes, they discovered something astonishing. Normal bird feathers are flat, acting like tiny mirrors that reflect light. But the feathers of the bird of paradise are shaped like microscopic bottle brushes or tiny, deep valleys. When light strikes these feathers, it doesn't bounce off. It gets trapped inside the valleys. The light bounces around inside the microscopic structure, losing energy with every single bounce, until it is completely absorbed. These feathers absorb up to 99.95% of all visible light. The evolutionary reason for this is beautiful but manipulative. By placing the ultimate darkness right next to vibrant blues and greens, the bird creates a visual contrast so extreme that the colors appear to glow with superhuman intensity. It is a trick of cognitive psychology, used to dazzle mates in the dim understory of the jungle. But nature's mastery of the dark doesn't stop in the canopy. It descends into the deepest, most hostile environments on the planet. Deep in the ocean's midnight zone, where sunlight never penetrates, scientists discovered something even more terrifying: ultrablack fish. Species like the Pacific black dragon or the fongtooth swim in a world of absolute pitch. However, many deep-sea creatures generate their own light through bioluminescence to hunt. To avoid being seen by these biological searchlights, these ultra-black fish evolved a skin made of a continuous layer of closely packed melanosomes, tiny structures filled with melanin, the same pigment that gives human skin its color. Unlike our skin, the melanosomes in these fish are sized and shaped perfectly to scatter and trap light. When a predator shines a bioluminescent light on them, the skin absorbs 99.5% of it. The fish becomes a shadow swimming through a shadow, completely invisible. For centuries, these biological marvels were the undisputed kings of the dark. But humanity is a species defined by its refusal to let nature have the final word. In the early 2000s, scientists and engineers realized that if we could replicate the light-trapping structures of nature on a molecular level, we could unlock technologies never before dreamed of. We could create telescopes that could see the dawn of time without being blinded by stray starlight. We could create solar panels that capture every single photon of energy. We could create the ultimate stealth camouflage. The breakthrough came in a laboratory in the United Kingdom. A company called Surrey Nanosystems announced to the world that they had created a material so dark, it set a new Guinness World Record. They called it Vantablack. Vantablack is not a paint. It is not a pigment. It is an acronym, vertically aligned nanotube array black. Imagine a forest. But instead of trees, this forest is made of carbon nanotubes. Each nanotube is a hollow cylinder made of a single layer of carbon atoms. To put their size into perspective, a single human hair is about 80,000 nanometers wide. A single carbon nanotube in Vantablack is about 20 nanometers wide. When you grow billions of these nanotubes standing upright, packed tightly together on a surface, you create a microscopic forest. When a photon of light hits this forest, it enters the spaces between the tubes. Once inside, it cannot simply bounce back out. The light is forced to bounce between the walls of the nanotubes, over and over and over again. With every bounce, a fraction of the light's energy is converted into heat. By the time the light has finished bouncing, it is gone. Vantablack absorbed 99.965% of all visible light. When scientists coated objects in Vantablack, the results were profoundly unsettling. If you coat a highly textured, three-dimensional object, like a crumpled sheet of aluminum foil, or a plaster bust of a human face, in Vantablack, all features instantly vanish. You can no longer see the ridges of the foil or the nose and eyes of the face. The human brain, stripped of the reflections it relies on to understand depth, panics. It interprets the object as a flat, bottomless void. It looks as though someone took a pair of scissors and cut a hole right out of the room, revealing a universe of nothingness behind it. The psychological impact of Vantablack was massive, but it quickly became the center of one of the most bizarre and bitter feuds in modern art history. An artist named Anish Kapoor, famous for designing the Bean sculpture in Chicago, saw Vantablack and realized its immense artistic potential. He struck a deal with Surrey Nanosystems, purchasing the exclusive artistic rights to Vantablack. This meant that no other artist in the world was legally allowed to paint or create with the blackest material on Earth. The art community was furious. They argued that a color, or a lack of color, should belong to humanity, not a single billionaire artist. In retaliation, a British artist named Stuart Semple decided to fight back. He created a pigment called the pinkest pink, a vibrant, fluorescent powder. He put it up for sale online for a few dollars, but with a strict legal condition, anyone could buy it, except Anish Kapoor. Buyers had to legally sign a waiver confirming they were not Kapoor, and were not associated with him. The feud escalated into a legendary piece of performance art. Kapoor eventually got his hands on the pinkest pink, dipped his middle finger in it, and posted a picture on social media with a profane caption directed at Semple. In response, Semple spent years working with scientists to create his own version of an ultra-black paint. He called it Black 2.0, and later, Black 3.0. While not as black as Vantablack, it absorbed 99% of light, smelled like black cherry, and crucially, was available to anyone in the world to buy, except Anish Kapoor. While the art world was busy fighting over who owned the void, the scientific community was pushing even further into the dark. Because as black as Vantablack was, 99.965% was still not absolute zero. There were still a few rogue photons escaping the forest. In 2019, engineers at the Massachusetts Institute of Technology, MIT, were working on a completely unrelated project. They were trying to grow carbon nanotubes on electrical materials like aluminum to boost their thermal and electrical properties. But they hit a snag. A layer of oxide always formed on the aluminum, blocking the electricity. To fix this, they washed the aluminum in salt water to strip away the oxide, and then grew the carbon nanotubes. When they looked at the resulting material, they gasped. It didn't look like carbon nanotubes. It looked like nothing. They measured its light absorption. The results shocked the scientific world. This new, accidental material didn't just match Vantablack. It shattered the record. It absorbed 99.995% of all incoming light from every single angle. It was 10 times blacker than Vantablack. To demonstrate its power, the researchers took a brilliant, 16.78-carat yellow diamond, worth over $2 million. Diamonds are famous for their unparalleled ability to refract and reflect light, sparkling with brilliant clarity. The researchers coated this priceless diamond in their new ultra-black material. The result was stunning. The diamond completely disappeared. It didn't look like a black diamond, it looked like a flat, shadow silhouette in the shape of a diamond. The facets, the edges, the sparkle, all swallowed by a microscopic forest of carbon. It was an ultimate testament to human ingenuity. We had created a material that could make a multi-million-dollar gemstone look like a literal hole in space. But why do we care? Why are we spending millions of dollars and decades of research to find the blackest thing on Earth? Is it just for parlor tricks and artistic feuds? The answer lies above us, in the stars. We are currently living in a golden age of space exploration. Instruments like the James Webb Space Telescope are peering into the deepest, furthest reaches of the cosmos, looking for the very first galaxies that formed after the Big Bang, and searching for faint atmospheres around distant exoplanets that might harbor alien life. But looking into deep space is incredibly difficult. The light from these distant stars and planets is incredibly faint, sometimes just a few photons strong. If a telescope is pointed toward a distant galaxy, but a tiny fraction of light from a nearby star bounces around inside the telescope's housing, that stray light will wash out the image. It's the equivalent of trying to see a firefly hovering next to a massive stadium spotlight. By lining the insides of space telescopes and camera housings with ultra-black materials like Vantablack or the MIT nanotube structure, scientists can ensure that any stray light entering the telescope is instantly swallowed and killed. Only the pure, unadulterated light from the edge of the universe reaches the sensors. In a very real way, the blackest things on Earth are the keys that unlock the brightest secrets of the cosmos. But the search for the blackest thing doesn't stop in our laboratories. If we broaden our definition of a thing, the ultimate title of the blackest entity in existence doesn't belong to a bird, a fish, or an MIT lab. It belongs to the universe itself. It belongs to the black hole. A black hole is the ultimate realization of what these scientists are trying to build. In a black hole, gravity is so unimaginably intense that the escape velocity exceeds the speed of light. This means that nothing, not even light, the fastest thing in the universe, can escape its grasp once it crosses the event horizon. When light hits Vantablack, it bounces around until it turns into heat. But when light hits a black hole, it doesn't turn into heat. It is crushed into an infinitely small point of infinite density called a singularity. A black hole absorbs 100% of all light, completely and permanently. It is the absolute zero of color. It is the true, final boss of darkness. As we stand on Earth, looking at samples of Vantablack and MIT's ultra-black material, we are looking at a microscopic simulation of a black hole's event horizon. We are staring at a boundary where light goes to die. Human beings are creatures of the light. Our biology is wired to fear the dark, because the dark represents the unknown, the hidden predator, the loss of control. But through science, we have transformed that fear into a tool of discovery. We have gone into the deep jungles, descended into the midnight zones of the ocean, and rearranged the very atoms of carbon to manufacture our own abyss. We sought out the blackest thing on Earth not to hide from the light, but to understand it. Because it is only in the presence of absolute darkness that we can truly begin to see the light of the universe clearly. We stared into the void, and instead of blinking, we built a telescope.